Hello. So in today's video, I'll be showing you the quantum mechanical model, which is the modern model used when determining the location of an electron, as well as explaining the main reasons why uh, the quantum mechanical model was created. The model that was disproved with the quantum mechanical model, and finally, who made the quantum mechanical model and who made the previous model. So let's just start off with the model that the quantum mechanical model disproved, which is the Bohr's atomic model. So the Bohr's atomic model looks something like this. It looks like a couple of circles, and in the middle circle there would be protons and neutrons, which would be the nucleus. But then there would also be these atomic orbitals, are these surrounding circles. Atomic United Airline shares orbitals. And so there's a couple of them. And in the innermost ring, there would only be two electrons. But as the rings get further apart, there would be more electrons. So the this model, Bohr's atomic model, was very widely accepted until they found a contingency and a fault in this model, and that was for things with more than one electron. So the only element that this really applied to, and however it applied very well to this element, was hydrogen because it only included one single electron. But then with any other element, for example, gold or carbon, it wouldn't work very well because they have multiple electrons in one atom. So that's when the quantum mechanical model was thought of. So Erwin Schrodinger, he was I believe, Austrian physicist in the early 1900s, and what he was responsible for was creating the quantum mechanical model. I apologize for my bad handwriting; it's very bad. And so he wrote the quantum theory to solve mathematical equations in determining the location and energy level of an electron in atoms. And the first atom that he experimented with was hydrogen. That's just a random fact. So so the modern description on how to find a electron in the atom comes from the quantum mechanical model. So let me just draw the quantum mechanical model. It would look something like this, and inside here's the nucleus, and pretty much what this titles is this outer area. So anything else excluding this, okay, the nucleus, would be sort of a fuzzy cloud, as many people describe it, of electrons. And pretty much what it said was in the areas with an electron. So let's say the electron is right here. We would not be able to see it, but there would be a 98% probability that the density in this location, in this little area, because there's an electron here, would be more dense, which would allow for scientists to find where to find the location of these electrons. So uh, yeah, so the probability was around 90%, and this was used. This is the modern theory that we use today, and it hasn't necessarily been disproven yet, which it may be in the future.